G'day everyone, it's Corey from CAD with Corey. How are you today? So a little bit of a different video today. Normally I'm sort of just drawing a little product or a little sample or showing you a different technique on how to draw a hole or something in a project on Fusion 360. But today we're in the shed and there's probably going to be a little bit more of this hopefully because I want to get back into more shed steel fabrication stuff. So today we're talking tube, pipe and tube benders. Now I have one, you can see here, it's a JD2 Model 32 bender. It was the manual version and it came, I've had it for many years, and it came with the bender. I bought two dies with it. I bought a 40 NB pipe die because that's quite a common pipe in Australia where I live, quite cheap, and I also bought a 1-inch die to just do some smaller stuff as well. So we'll just get a quick pic of the bender itself. Now this one I've actually put in a vertical orientation and I have made it hydraulic. So it's actually a 12-volt hydraulic pump that runs through a 3-inch ram, and it is powered in that little battery box down there by a 12-volt car battery, just like a battery out of a 4-wheel drive. So it works extremely well, and we'll do a little test bend on this 40 NB a little bit later in the video. Now I'm going to try and explain some technical information about how to work out lengths of pipe or tube when you are to use a bender like this. I can only sort of vouch for this type of bender because I don't have any other tube benders. I've never used any other ones. There is quite a few on the market, but I have this one. So a few things to note that you kind of need to know the meaning of. First of all, CLR, or center line radius. What is a center line radius? Well, we know what a radius is. It's like from the center point of a circle. So you've got a circle. From the center point to the edge of the circle is the radius. So that's half the diameter. So in this case, here's a bit of pipe that I have. This is just a bit of scrap. So the center line radius is not the inside of the pipe. It's not the outside of the pipe, it's the center of the pipe. Now I'll just get a file, right, and this will explain it. This will show it quite easily. So if I just lay this flat on the bench, I get my file and I just run this over the top. Again, this is scrap, it doesn't matter. You can just do it with a texter if you want. So can you see that mark there? Right, that is my center line radius. So when I go to measure something, if I want to measure from here to here, I need to know how long that length is along that line for my bend and how much pipe to allow when I cut the length and when I'm making a roll cage or a hoop or just a single bend even in general. How long is that bit of pipe there and what's the easiest way to work it out? Well, you can just draw it in Fusion and click on it and it will tell you the length. That's probably the easiest way. But if you're not too familiar with that, what we'll do is a little bit of technical math. Now brace yourself because this will be interesting. Right, we'll get a fresh page in my little book here. So, what do we know? We know that this particular die that I have is a 40 NB pipe die and it is 165 millimeter center line radius. I do everything in millimeters. So 165 millimeters. Now I'll try and write this upside down here. So 165 millimeters is the radius. Okay. Now what we do, I'll just push this out the way a bit. Now what we do is we times 2, and that gives us the diameter. So 165 times 2 equals 330. And we'll put a D for diameter. So 330 millimeters is the diameter. Now we times the diameter, right, by pi. So we'll just call it 3.14. I can't even draw a 4 upside down, let alone normal way. 3.14. And that will equal something. So we'll just do a quick calculation on the phone. So 330 times pi equals a meter 36.7. That is, we'll put C for circumference. Okay, so radius times 2 equals the diameter times pi equals the circumference. Pretty easy? You with me? Stay with me. Then, so we know that we need 1036 millimeters to make a full circle of pipe on the centre line radius. So if I do, we'll just clear that. So now we do 1000. We'll call it 1037 because that's 36.7. So we'll go 1037. Okay. Let's see if I can do this. So 1037, which is just rounded up from that. Right. Now we divide it by the amount of degrees in a circle, which is 360. So forgive me because I'm upside down. Divide by 360 equals 2.88. So if I go divide 360 degrees equals 2.88. 2.88. Now that, to me, that is, I need 2.88 millimeters of pipe per degree of bend. So I have it written on my die. I have it written on all my dies, actually, right? So I just know, okay, I want a 40 degree bend. I do 40, so 40 degrees times 2.88 equals 115.2 mil. So I know to do a 40 degree bend, I need 115 millimeters of pipe. So when this is straight, right, when this is straight, I know from here to here, I allow 115 millimeters on that bit. So that works out pretty easy once you work out that little calculation, and it's written on all my dies, like I said. It's very handy to know that. So we'll do that on another die just to show you how it goes. So this is a 1 inch die, 1 inch tube die, and it has a 3.5 inch centre line radius, which equates to roughly 89 millimeters centre line. So 89 millimeters centre line. So I'll do this here. I'll talk my way through it. So 89 millimeters is the radius. So 89 times 2 gives me the diameter. Then I times the diameter with pi, and it gives me a measurement of 559.2. So 559.2. So 559, we'll just call it 559 millimeters for a full circle. So 599 divided by the amount of degrees in a circle, which is 360, equals 1.66. So 1.66 millimeters of tube per degree of bend to suit that die. Now you can work this out to all your dies and just write it on there. Okay, so if I want a 90-degree bend and I'm doing some 1-inch tube, I just know I do 90 degrees, so type in 90 as the degrees, times 1.66 is 149.4 millimeters. Now you can round up or round down, depends on how fussy you want to be. I normally just round up. So in that case I'd go 149.4, I'd just call it 150 millimeters. I'm not really building anything that's that technical that it needs a 0.5 millimeter difference in the length of the bend of the tube. So hopefully that covers how much tube you need per bend, and as I said, work it out with whatever die you have. Now let's just go through a few things of what I find handy using tool-wise when it comes to doing a bend in actual pipe. Alright, so first things first, a very handy bit of gear to bend pipe is an actual bender. As I said, this is a JD2 Model 32. I have a couple of dies for it. In Australia, dies are quite expensive to buy. So a few things that I use is I use a little digital protractor. Alright, I have 2 of them. They're quite handy. I'll probably even buy a 3rd because they're just very handy to have. Now I do keep them in a little bag and in a box just to keep all the dust and grime out of them, and I only bring them out when I want to use them on here. Next thing I use is, I find these quite handy, a magnetic level, right, which just sticks to the pipe, and I have 2 of them, just because. Now I must admit I don't use these as much. I started to use these before I got the little digital protractors, and I find that I do use the digital protractors a bit more. Next thing is a digital angle finder. Now these kind of spread out like this. This one is actually got a flat battery, I do believe, and it's not working. But it does give a degree measurement on here as you spread them out. Now I have a variety of these in different length rulers. I think I've got this one, I think I've got like a 300 and a 600 maybe. I can't remember the size of the bigger one, but it's a bit bigger. Now they're good for when you're measuring an angle, say in your car or whatever bit of tube you want to bend. You just tighten it up and it gives you the degree on there. Handy bit of gear. Next thing I use is, I do use a bit of lubricant on the die. I'm not really that fussy about what I use. I just happen to have a can of Onyx here, some CRC, any kind of like spray lubricant. I find I put some on the die and I put some on the follow bar as well. Now just a quick one, the follow bar is this device here. That's called a die, that's called a follow bar. So this, your tube lays in that, and the die actually pulls the tube around through the follow bar. Now another thing I like to do is I like to keep the die and the follow bar surfaces in good condition. So they regularly get sanded with, say, like some 600 wet and dry, with a bit of like spray, with a bit of spray or something. The follow bar is made out of some grade of aluminium, and it does. I have had this one gall up when I did a bit of aluminium tube once, but since then I've polished it and just kind of rounded the intake edges a little bit. Pardon me. And just kind of rounded the intake edges a little bit, and it really made a difference with that on aluminium. It did. So that pretty much covers the tools that I have to bend tube with. Another thing that I sometimes do is I will get a little off-cut bit of steel angle and I will weld it to the tube. Right, if I'm doing, say I'm bending a tube that has, say, one bend on one plane and then it's rotated, say, 10 degrees, and you do another bend, so the two bends are kind of offset to each other. I will weld this onto the tube, and then I can use my digital finder here, which magnetizes to it, and that will give me the roll orientation of the tube. Once I've done one bend, I go, yep, okay, I'll do a 40-degree bend here. Now I need to twist it 10 degrees, and generally you're making two of the same pipe. If it's for like a car, for example, you'll do one will go 10 degrees to the left, one will go 10 degrees to the right. So I have marked, you can't see it, but on this side of the die, I have the letter R. So I know that, because I work from this side, I know that I'm on the right side. Not necessarily the right or the left side, but to me, this is the right side. So I know that if I'm going to bend it to the right, I bend it towards me. If I'm going to bend it to the left, I bend it away from me, because I have the letter R just here on this die. Make sense? Makes sense to me. Right. So, next bit about what I've found. Okay, so the next bit, what I've found with this particular die in this bender, is that when I'm bending the 40 NB pipe, normally I'll just take this bar out. Normally, I would line my mark where I want bent up with the edge of the die. Okay? Now I found that that's not exactly correct. You may be a little bit different, but I've done several test bends in different locations from here, and I've kind of figured out that my bend is actually about 15 mil in from the edge of this die. Okay? Now each die might be slightly different depending on what size and radius your die has, but I know on this one, and this is the one that I use all the time, 15 mil in from the edge of the die is where my bend starts. Now, if you're familiar with bending pipe on this bender, you'll know that it's pretty hard to see the edge of the die, past this bar here when it's all kind of set up, ready to go. So I have basically measurements, set measurements for everything. 115 mil from there to my bend. So I know that if I lay my pipe out and I've marked all the measurements on the pipe that I'm going to bend, I would measure back 115, and 115 lines up with here, and I know that I'm right. So again, check your bender, check your die, but that's just how I do it. Okay, so we'll just pop this back together and we'll put the follow bar in and we'll do a test bend and we'll just explain spring back. So we'll just put this back in there. I'll get the follow bar here. Follow bar can go in. Done. Now what's spring back? Well, spring back is when you bend a piece of tube or pipe. You bend it, example, 90 degrees. Now if you bend it 90 degrees on the indicator and it says 90, 100% chance when you back off the pressure of the bender, it'll read less degrees. Anywhere from 2 to 5 degrees, depending on the thickness, the wall thickness of your steel that you're using. Now, I know that if I use 40 NB pipe, which is about 48 millimeters in OD, common wall thickness is about 3.2 millimeters, roughly. Now, I'm getting close to 3 degrees spring back on that size. That will vary depending on the grade of steel, the thickness of steel, you know, the temperature. I suppose there's a few things. If you call it 2 to 3 degrees spring back, you're pretty much in a safety area there of being spot on. So whatever degree bend you want, add another few degrees, and you pretty much will be there. Now I would also recommend wasting a bit of pipe, getting a few little offcuts, and going, okay, I want to bend this at 45 degrees, and bend it at 45 degrees on your little dial. Take it out, measure the degrees with your angle finder, and go, okay, so I bent it at 45 on the machine, but it's telling me 43 on the angle finder. So I've got 2 degrees spring back. So bend another one at 47 degrees and then measure it again. And once you work out these little bits and pieces, it makes bending very easy. So let's just bend a bit of pipe. Alright, so as you can see, this is a fully portable 12 volt powered bender. It is heavy, yes. It's on wheels just so I can move it around in the shed. If I wanted to pick it up and take it anywhere, I could pick it up and take it anywhere I like, and I don't need power or anything to use the bender. So I've done a pretty simple wiring setup. I've just done a switch here, a button, a momentary button which activates the motor, and I've done a direction of the motor. So I know that if I have it out there, we're going to bend, the ram will extend. If I have it here, the ram will contract. Pretty simple setup. It is. The motor doesn't need to run all the time. It only runs when you push the button to activate the bend. So what we'll do is we'll just put a bit of, we'll just do a little bit of spray on here. Right. Now this is galvanised pipe. It's the only offcut that I actually have at the moment, being Christmas time here in Perth. Most shops are shut. So, okay, so we're on the outward. Now we just take up the slack. I'll bring you around here. So now we get our little degree angle finder. We put it on the pipe, turn it on, probably helps. Right, zero it out. Now we're ready to go. Now we'll shoot for about 40, pick a number, jeez, I don't know. What year is it? 2024. We'll go for 24 degrees. So as I bend, the degree will change. Okay, now we're talking spring back. So I'm going to go to 26 degrees. Whoa, look at that. Overshot it a little bit, didn't I? So now if I back this off a tad, right, now we're free to take the pipe out if we want, and we have a bend in the pipe. Now what happens if you want to go further than that? You want to do, say, a 90-degree bend. Well, I'll show you how that works as well. So we just keep bending. We back it off, pull the pin out, slide the pin back in, and there we go. That's how it's done, easy. So to take the pipe out, we've backed off the pressure with the ram, and we know that the die spins freely. We just loosen off this bolt a bit. Let's put that down there. And then we pull this call that the pipe clamp bit, because I don't actually know its scientific name, but we'll just go the pipe clamp bit. And then the pipe is ready to come out. And there we have a lovely bent bit of pipe with next to no like deformity in it. It's actually really, really nice. And maybe a little bit here, just a little, you can just feel the slightest bit under my thumb there. But, piece of cake, eh? So, I hope that, like, shined a bit of light onto bending some stuff and working out degrees per bend, per degree of bend. And as I said, once you've got it, once you've worked out that bit of math, you've got it written down, you just remember it each time. This one's 2.88 millimeters per degree, and the other one is 1.66 millimeters per degree of bend. And once you know that, it makes life pretty easy. It does. All right. Thanks for joining me on something different from CAD with Corey. Now, I'm going to go back on the computer, load up this video, and put it out. I do have another channel. We do have another channel called Rockpile Off-Grid Homestead, which is us living in a remote location on how we've built our off-grid house. Totally off-grid, solar panels, batteries, no mains power at all, over the last few years. So there is a video on there. I think that's getting loaded up tonight, just on how I sort of built this and put it together. A little bit more insight into this particular bender. So if you want to see that, jump over there, check that out. You might find my humour funny, you might not. If you don't, too bad. See you on the next one.